Hello everyone, and welcome back to another Physics Friday, where we are going to be answering why a hot potato has more mass than a cold potato. And that's why there's a Minecraft potato on screen. So let's get straight into it. One way we can express the mass of really any object, but say this potato in particular, is E equals mc squared. You know, the general famous formula, right? But say that's our potato at state 1, right? So E1. And then say we want to heat our potato up. You know, maybe we get hungry or we want to boil it for the sake of science, or maybe we're just hungry, I don't know. But the point is we're going to be changing the energy of our aforementioned potato. So what we have then is a second energy, our E2, which is going to be equal to mc squared. But one thing you might note here is that, well, if we're adding energy to our potato, we're heating it up, well, the energy couldn't necessarily stay the same. So that can lead you to one of two things. Either the potato has disproved relativity, if we take the mass of the potato as constant, and the speed of light actually does vary depending on how much mass our potato has. Or we could just say we could just say that the mass of the potato does in fact vary. So to actually measure this difference, let's take the difference of energies of our potato, right? So let's do E2 minus E1. So E2 minus E1. Well, that's just going to be what? M2 minus M1 times C squared. But what we're doing is taking the difference in energy of our potato. And we also know that we can express the difference in energy in a second way. Namely, actually, through thermodynamics. And that right there is going to be a change in internal energy. And what exactly is a change in internal energy? Well, this can be approximated, actually, as a change in enthalpy. All right, that should actually be capital H, I suppose. I swear I learned something in thermodynamics. It was actually a really good class. But anyway, that right there can be approximated as a change in enthalpy, which can in turn be approximated as the mass of our potato, say, times the specific heat, I'm going to say Cp, times our change in temperature. What we now see is that we have two different changes in energy, but we know that those two effectively must be the same, right? So what we can conclude, kind of zooming in on here, is that M2 minus M1 times C squared is equal to the change in our internal energy. So the change in our rest energy is equal to the change in our internal energy. So we're going to say, I'm going to call this M1 actually, because that's like where we're starting from, because presumably we're like heating it up, right? So M1 times Cp times delta T. So since we're interested specifically, and perhaps rather oddly, with a potato, we can say that M1, the starting mass of our potato, is equal to 0.25 kilograms. And I believe that would actually be slightly an above average potato in terms of mass, but I don't think that's necessarily the biggest concern of ours at the moment. So with that in mind, we can say that the difference in mass, right, delta M, is equal to all this right here, but then just divided by C squared. So what we have is then 0.25 kilograms times the specific heat of our potato times the temperature, how much we're changing it, and then divided by the speed of light squared. Now, you might be wondering, what on earth is the specific heat of a potato? And that is a very good question. One that I do not necessarily have the answer to, nor just Google for that matter. So what we're going to be doing is say the specific heat, so Cp potato, is going to be, that should be an O, my goodness. You can tell this is a math channel. I misspell things all the time. That C potato is going to be approximately equal to that of water. So the specific heat of water. And the reason for this might seem, a little bit silly at first, but then if you actually Google it, potatoes are like 80% water. So, I mean, if a potato is like 80% water, I mean, that, to me at least, is grounds to approximate it as, water. The rest being like starch and other things like that. But anyway, we're going to be approximating our potato as basically a quarter kilogram of water. But anyway, that's basically what it is, right? Throw some salt on it and call it some fries. Anyway, that means that our change in mass of our quarter kilogram potato is then the following: 0.25 kilograms times our specific heat of water. And it actually should be noted that 4.18 is the specific heat of water, but the unit for this involves grams rather than kilograms. So in order to convert it, we are going to be just kind of moving the decimal point over a couple of spaces. And then we have our change in temperature, and this just kind of depends how much we want to heat it, right? We could have like a frozen potato to boiling potato. I think that would work quite nicely. So that just makes our change in temperature 100. Temperature, in this case, since it is a change, it can be in, I guess, Celsius or Kelvin, because, again, it is a change, right? So those two scales, when you subtract one value from another, doesn't necessarily which scale you use as long as they're the same, because one is just a shifted over version of the other. And then divided by c squared, which is just going to be 3 times 10 to the 8, and then all squared. So the change in mass for our potato then is equal to 1.16 times 10 to the negative 12 kilograms. But we can actually rewrite this in a slightly nicer way, actually. That being that 10 to the negative 12 kilograms is the same thing as just a nanogram. So this right here is just going to be 1.16 nanograms. And that right there, if we have a potato and it's like, basically frozen, and we heat it up to boiling, that right there is our rather negligible change in mass. And this actually can't really be measured, because the most precise scales in the world, at least according to, I think, Wikipedia, can only measure differences in weights or masses many orders of magnitude, I think like 3-4 orders of magnitude higher than nanograms. So unfortunately, I don't think we will be able to observe the fact that a hot potato is heavier than a cold potato for a little while longer. So this might be one of the shorter Physics Fridays, but nevertheless, I thank you all so much for watching. Hopefully next week, or the next Physics Friday, will be a bit more grounded in maybe some more applicable items in physics. But at any rate, hope you all enjoyed this video, and I will see you in the next one.